شباب السلام عليكم. Today we shall solve a P3 question from a recent exam paper. The question is number 8. That the curve C has the equation e power 3x sec 2x. The angle x is between negative pi over 4 and pi over 4. Finding the derivative of g of x. Before we do so, we need to remember some rules for this specific question. And just copy the question. It's gx equal e power 3x sec 2x. Remember the derivative of sec. Sec of any angle like u has a derivative u dash, or the derivative of the angle itself, times sec the same angle times tan the same angle. So derivative of sec u is u dash sec u tan u. Second rule required here is a derivative of exponential function e power any function u is equal to derivative of the exponent u dash times e power the same exponent with no change. Rule number 3, derivative of logarithmic function ln u is equal to, the function will be the same at the denominator, and derivative at the numerator, u dash over u. These are the required rules to remember for this question. Finding the derivative here, because this is a product of two functions of x, so we'll use the product rule, which is u times v dash plus v times u dash. That will be equal to, the first will be the same, e 3x multiplied by sec 2x, that is, as we have just mentioned, 2 sec of 2x times tan of 2x plus the opposite, that we'll write the second one the same, sec 2x times derivative of the first, that is 3e power 3x. So you can put it in a simpler form, 2e power 3x This is a simpler form for the derivative of the function g. Here we have done the part A of I. The second part of the question is to find the x coordinate of stationary points. Stationary points, as you sure know, are found by making the derivative that we have obtained in part A equal to 0. So for B, we'll take the derivative e power 3x equal to 0. Solving this equation, but before you solve the equation, you have to notice something important, that the angle was determined to be between negative pi over 4 and pi over 4. This is x. Okay, remember this. But we have here 2x, so we'll modify the range. I'll tell you how now, but just before we solve, we shall take a common factor, e power 3x sec 2x multiplied by 2 tan of 2x plus 3 equal to 0. So we have 3 parts to be equal to 0. Before we have the parts, as I told you, we'll modify the range. Instead of x, I'll make it 2x. It was negative pi over 4. Now it will be negative pi over 2 and positive pi over 2. This is the new range of the angle. Now we have 3 possibilities. The first part may be equal to 0, e power 3x equals 0. The second part, sec 2x equals 0. The third part, tan of 2x will be equal negative 3 over 2. You have to know that e by any power can never be 0, so this will be rejected. It will give no real solution. Also, no angle will give sec 0, this is specific range, so we'll obtain no solution from this part. So the solutions that we are going to obtain are only from here. How can we find the solutions here? As you know, normally, this is a simple trigonometric equation. Tan is negative. Which quadrants have negative tan are the second and the fourth quadrants. Then we'll insert this, shift tan 3 over 2 positively, and find the angle here in the second or in the fourth. But because the angle is between negative pi over 2 and pi over 2, so from here to here, yani we'll just pass through only these 2 quadrants, first and fourth. So the solution in the second will not be in this range. Solution of the second quadrant will be out of range, so we'll find only this solution negatively. So the value of 2x will be equal to negative 0.983 dividing by 2, so x will be about negative 0.491. So this is the only one solution can be obtained. This is existing in the range of x between negative pi over 4 and pi over 4. This is a check you have to do. So solution is negative 0.491 radian only. Here we go for the third part of the question. If it's required to find the coordinate of the stationary point, so for the stationary point in the previous part will be negative 0.491 as an x. Then you substitute by this value to find the y coordinate. Substitute by this value at the original function to find the y coordinate. Now the third part, that is double I, x equal ln sine y. Y is between 0 and pi over 2 or 90, an acute angle. Show that dy dx is equal to e bar x over a function of x. In order to solve this, as x equals ln of sine y, look here, you can find dx dy that equals, as we said previously, rule of derivative of ln will be sine y in the denominator and cosine y in numerator. Making this as dy dx, so dy dx will be equal to sine y over cosine y. But it's required in terms of x all. It has to be e bar x over a function of x. So remember the original equation, this equation. From this equation, you know that converting this to exponential e will be power x equal to sine y. E power x equals sine y. Now you know that here it will be e power x. Now we replace the numerator by x. We need to do so for the denominator. How to convert the cosine y as a function of x? If you know that sine y equals e power x, and you know that sine squared of any angle plus cosine squared of the same angle is equal to 1, an identity. So sine squared means this squared. So it will be e power 2x plus cosine squared y is equal to 1. So cosine squared y equals 1 minus e power 2x. Finally, cosine y can be written as the square root of 1 minus e power 2x. So this is the final step required here. Back to the question. So numerator sine y will be from the previous step e power x, as mentioned, and cosine will be the square root found in the last step, 1 minus e power 2x. I hope this is clear. Thank you and good luck. Assalamu alaikum.